10, 9, 8, 7, 6, 5, 4, 3, 2, 1, and we are live. Hello world, it's Siraj, and what you are seeing here is a demo of TensorFlow running on an M1 Mac Mini. That's what I bought. I bought an M1 just for you guys so we could test it during this live stream. That's what you're looking at right here. This is an M1 device, and I've got TensorFlow running on it, Docker, CUDA, all the tools that we know and love. I've got it running on M1. And during this live stream, I'm going to ask you some questions. And at the end, 3 people are going to win $175 in Bitcoin. Now, I also know that Bitcoin is illegal in India. I'm aware. But the truth of the matter is no government can ever ban Bitcoin. All you need is any computer and an internet connection, and you can open a Bitcoin wallet. I will send you that money. It's the easiest way to send money internationally. That's why we're using crypto. And once you have that Bitcoin, you'll have to find out how to transfer it into rupees or whatever your local currency is. There's always a way, all right? And it's much easier than PayPal or any of those other payment mediums. So what we're gonna do is we're gonna look at M1, we're gonna install CUDA, we're gonna install TensorFlow, we're going to install all of those essential tools that we need for deep learning during this stream. So before we start with the M1, I've got to explain 5 minutes worth of processor knowledge to you. So get ready for some processor knowledge. And once we're done with the processor knowledge, we'll start installing everything and we'll start asking you all the questions. You guys know how the game works by now, right? So let's start with the M1. So the first thing I want to say about M1 is that I definitely bought into the hype. I literally bought into the hype because Apple is one of the best companies when it comes to marketing their technology, right? They've got this amazing team of technical writers, which I really admire as a technical writer. And they say that M1 is Apple's first custom processor. Normally, Intel is a company that makes processors, or AMD, and that's what we're used to. Apple computers use processors from Intel and from AMD. Why? Why doesn't Apple just make their own? Because making a processor is an extremely expensive, difficult process that requires a lot of basically PhDs in different subjects working together. It's a very interdisciplinary field involving electrical engineering, mechanical engineering, and of course, computer science. And so that's why Apple hasn't done it so far, but now they decided to do it. They decided to make their own processor. And they call this a system on a chip. So it's got both a CPU and a GPU embedded into one chip. Usually these are separate, but Apple put them together. On top of that, they also have what they call a neural engine, which of course, you know, I'm going to buy anything that says neural engine, which they left very vague. They didn't say how that works or how that's working with the CPU or the GPU. They just say it's a separate component. And so at the end of this stream, we're going to try to hack into the neural engine and we're going to try to trigger it somehow. My friend George Hotz already did this. He did like, I think 15 hours of streaming worth of like neural engine hacking, which was very inspiring, but we're going to try to condense what he did into like 10 minutes at the very end. But first we got to do our installation stuff. So that's the M1. You know, they really sold it really well. It looks really cool, right? Like, I'm really into this. Like, of course, I'm going to buy this and try it out. But before we get into the details of M1 and all of its glorious components in terms of software, we have to talk a little bit more about the different classes of processors out there. Now, remember what I said before. We've got Intel and we've got AMD. Those are the 2 behemoths. And both of these companies make 2 different types of processors. They specialize. Intel builds what are called x86 processors, and AMD builds ARM processors. Actually, ARM is a company that licenses out its technology, and NVIDIA just acquired it. And actually, ARM reached out to me like 2 months ago to do some education for them, but it didn't work out. I think I might have I'm really not that great at business development as I would like to think. I have made several really good deals happen, but ARM, if you're listening, I'm still open. But anyway, so x86 versus ARM is what the computer processor war has been all about before Apple came in with their M1. And I think this image really describes the difference between them in a computer sciencey way and also a very simple way. x86 processors can compute an operation like this. So this operation is we're going to just multiply two numbers together, store the locations, and then store the locations again. So multiply, store, store. So there are several steps that we could turn this into. And on an ARM processor, this process is 4 steps. But on an x86 processor, we can do this in one single step. So you might be thinking, well, if an x86 processor can do that in one step, why would we go for an ARM processor? Well, there's a lot of different reasons, but there's one major reason. And the major reason to use x86 over ARM is because of power efficiency. ARM doesn't require as much power as an x86 processor. So you can run low power devices. Think Internet of Things, think Arduinos and custom robots that you build. That's why ARM is still used, even though it's less efficient in terms of number of steps required to complete a task. But Apple came in and they were like, you know what? We don't need any of those. We're just going to do our own processor. And the thing is, as computer science enthusiasts, for us, that sounds really cool because it's like, well, of course we're going to want the best, latest processor that's like, what could go wrong? Well, let me tell you what's going to go wrong. What's going to go wrong is that for us developers who are building deep learning tools, building deep learning applications, web apps, mobile apps, anything consumer facing like a service, an API. Maybe you want to put a paywall on it. Maybe you want to build your own business with machine learning, as you should as an independent person. I always encourage people to start businesses over getting employment somewhere because I believe that that is the future of work, is that we're all going to be independent contractors, I guess you could say. And then for individual projects that we're into, we'll just form these groups, collaborate, and then disperse, and collaborate and disperse. And I think that's the future of work. Anyway, these tools right here that you're seeing are the standard suite of deep learning tools. All right, Docker, TensorFlow, CUDA, Python. And guess what? The developers behind these tools had to create versions of these tools, compatible versions for x86 and ARM. Because the M1 is neither of those two types of processors, we have to rebuild all of these tools just for M1. And honestly, that's really annoying. Like, we shouldn't have to do that. And the performance gains from M1, clearly all these tech YouTubers are talking about the performance gains. They're probably paid by Apple, maybe, I don't know. Overall, let me just say my review of M1 is that I don't like it because none of my tools here work really well. I did manage to get TensorFlow working, which we're going to do, but overall you're going to see a lot of the open source tools where the developers aren't paid to port anything to M1. It's going to take some time to port all this stuff to M1. So if you're a developer and you want to do deep learning, let me just flat out say it before we get any further into the stream. Do not buy an M1. It's going to be super annoying. Just get an x86 computer, Apple computer. Don't even buy Apple, to be frank. Go get a Linux computer or a custom PC. I got an RTX 3080 right here that I just bought because I lagged out of the stream last week. And only one of these was left in stock. And I will install this on Friday. We have a stream coming up in a few days, which I hope you show up for. But we're going to install this thing live for that, all right? So this is one of the best GPUs you can buy. So that's all of that. And I have one more image before we get into the actual installation. And then we're going to move forward, all right? So the last image that I want to show you is this image. Now, like I said before, I hope you studied at least a little bit of the ML compute framework from Apple, or at least, anything about ML compute. But here's the basic idea. Apple has a library called CoreML, and it's been around for years. It's nothing new. It's been around for at least 4 years. And CoreML is what a developer would use if they want to build any kind of machine learning into their iOS application, whether that's for mobile and whether that's for Mac, whatever that is, iOS based. And CoreML is this great framework because it's pretty easy to use. You can use it in Swift, you can use it in Objective-C, but underneath the hood, it's using these two different frameworks that you're seeing here. It's using BNNS, which stands for Basic Neural Network Subroutines, and you've got Metal Performance Shaders. BNNS is the CPU-specific collection of primitives that Apple built for machine learning. Metal Performance Shaders are a different set of primitives that Apple built for the GPU. And so together, that's what makes up CoreML. So where does ML Compute play into all of this? Well, ML Compute isn't a new framework. It's actually just a new set of classes that Apple developed, which is the exact next thing we're going to do. I'm going to show you ML Compute and why it was built for M1, specifically for M1 machine learning. All right, so let's bring up the M1. I've got the Mac Mini running on a different computer, and we're going to have both of these run at the same time, and we're going to see if it works on my new streaming ready computer, which of course it will, because it has to, you know. And then once we look at a little bit of the M1, what do I want to say? Once we look at a little bit of the M1 architecture, then I'm going to ask you the first question. So I hope you're ready for the first question, which is coming up. And I had those study guides for you in the video description. So those of you who were really paying attention will do well. All right, so that's what we're going to do. Let me open that up. Let me open up the full screen interface. And here we go. And I'm going to count down to 5. 5. 4. 3. There we go. All righty. Into the M1 we go. Here we are in M1 land. Now, I want to show you Apple's... Okay, before we even get to the Apple thing, look at this dramatic in the ML subreddit, this Timnit Gebru, ethical AI researcher drama. It's at the top of the ML subreddit. Guys, this is not what we want. This was what happened to me last year. We don't want the most dramatic content to percolate up to the top. The algorithms do, because that's what drives engagement. But we have to be aware that, you know, this is not what we want to focus our attention on. We want to focus our attention on the future of AI, the future of algorithms, the future of machine learning, and not some person and whatever controversial thing they did. I feel sorry for Timnit. Timnit, if you're listening, I feel sorry for you. When they come at you, they come hard. So anyway, let's take a look at ML Compute. So if we go to ML Compute by Apple, by the way, this is an M1. Let me go to the About. You can see right here, M1 confirmed. So that's good. Storage, not that much, but it's just like a cheap Apple Mini. Really sucks. I mean, everything is super fast on here, but it really sucks still. You'll see. So here's ML Compute. I hope you took a look at this framework, because what you have here is basically a neural network library that nobody talks about. It is essentially one of the best neural network libraries out there. And for low-level primitives, but we're not going to use it because it's so... We will use it, but nobody uses it because Apple doesn't I don't know why, but Apple doesn't market their software as much as they do their hardware. They should, because some of these classes are really interesting. But this brings us to our first question before we get into installation. So I hope you're ready for our first question. Here we go. First question. So the first question is going to be for you guys. I hope you're ready for the first question. Here we go. All right, let's bring up everything. I'm gonna activate the link so people can start answering. Give me a second here. We have a little bit of a new setup, so you're not going to be answering directly on item pool. Instead, you're going to be answering on playcoderoyale.com/live, and then you will be able to answer those questions. Go live, begin accepting answers. All right. I really hope this works. But okay, so go to playcoderoyale.com/live, put in some username, and then there we go. It's working. Great. Amazing. So here's the first question for you guys. The first question is, which of these classes is a part of the ML Compute framework? Is it A, MLC YOLO loss layer? Is it B, MLC neural engine layer? Is it C, MLC neuron firing? Or is it D, MLC compute biometric? So if you're just curious, MLC stands for, I think it stands for multi-layer connected. But you're going to see MLC all over the place in the Apple documentation. Now, let me answer 3 questions while you guys answer this, and then we'll get into our installation steps. Ready? Question 1 is from Mohammed Bashir Mohammed. Hello, Siraj. What do you think about research areas in the in AI ethics? First of all, no one cares about AI ethics when it comes to popularity. Of course, people care about AI ethics, but what I found is that anytime I make a video about AI ethics, people don't seem that interested. And let me specifically point to a specific video of mine. Anything that I do on differential privacy. Differential privacy is this idea that you can, train a model, you can have a data set, and you can share it, collaborate it with other researchers, other algorithmic experts, and they won't see what your data is. They won't see any of your sensitive information. The problem is that there's not as much money in that, and that's why there's not enough interest. If there's more of an incentive to look at AI ethics, if there was like an actual financial incentive behind that, I'm sure people would care more. Also, ethics is a really slippery slope because, we are not ethical. We cannot decide what good and evil is. Like what is good and evil, right? Between us humans, between cultures. And, I think that overall, when it comes to AI ethics, everybody should read the book Metamorphosis of the Prime Intellect. It's a book I'm reading right now, and it's such a beautiful book. It's not for audio. You have to read it. It's on Kindle. It's called Metamorphosis of the Prime Intellect. And it's a sci-fi book that talks about this future where we create this AGI, this godlike artificial intelligence that basically solves all of our problems for us and has a better sense of morality and ethics than we humans do. So I would say when it comes to AI ethics, let's just build AGI, because I don't even think our ethics are good enough. We have to build something more ethical, smarter than us, and then it will decide. Last question before we move on. Could you talk about ML ops? Okay, sure. That's what Tiaga Rajan said. So Tiaga, when it comes to ML ops, I think that TensorFlow serving is still the best library for serving ML models in production. When it comes to looking into the internals and plumbing of a model in production that's, thousands of people are making requests towards, I think that Rust has the most interesting ML operations libraries I've seen, and we have a video on Rust. When it comes to ML ops and the top tools, I would go to GitHub, type and search for machine learning and then Rust. Machine learning production, Rust, indexed by the most stars, and the first three are going to be the top ML operations tools, or at least really interesting. Let's now answer this question. It looks like this was a really hard question. Not everybody got the exact same answer, which is good. That's what I wanted. I wanted to give you guys some sort of a challenge because you guys are so smart. So let's see what the answer is, and then we'll keep going, all right? In 5, 4, 3, 2, 1. The answer was, believe it or not, wow, most people didn't get this one. I know it was hard, right? It doesn't seem like it's a real object, it's a real class, but it is a real class. It's called MLC, Multi-Layer Connected YOLO, which stands for You Only Look Once Lost Layer. Now you might be thinking, why is the word YOLO in a machine learning API? Just search YOLO Siraj on YouTube to understand why. It's called You Only Look Once. It was an algorithm introduced 2 years ago for object detection that was really popular in the ML community. Now we're at V3 of that, and apparently Apple encoded that into their default ML compute framework, which is awesome. Let's keep going here. All right, so we did that. Now let's get back into M1 so we can do our M1 magic. We're going to install TensorFlow. We're going to install CUDA. We're going to install a bunch of stuff. So here we are on our M1 machine, and we have a quest. Our quest is to be able to install TensorFlow and everything else that we need. So let's go and open that up, and we're going to install TensorFlow. We're going to install CUDA. We're going to install literally everything. All right, here we go. All right, here we are. And so what's the first thing to install? That's a good question, right? Should we install TensorFlow first? Should we install Docker first? Well, let's take a look at Docker. I think Docker is actually one of the best tools to install usually. Usually I would say let's just install Docker before everything, because Docker is a containerization service. All of your dependencies, if you download Docker and then you download what's called a Docker container. A Docker container could contain all of those tools that we need. It could contain TensorFlow and Python and everything else. But let's see. So we've got Docker for Mac here, and this Docker Hub, it's built for x86 and for ARM. So we want to search for Docker M1. Install Docker M1. Let's see what we got. Install Docker M1. Docker.com, November 16th. So this is a really new blog post. And they're like, okay, we've got some things going on. Build, run, share. Let's see the issue tracker. Docker for Mac. Let's just try to install Docker, not even for M1. Okay, so somebody got it working. It was like, I don't think Docker themselves have a really easy to use tool for this, but let's just see like if I even have Docker installed actually. Like I'm not even sure. I did install Docker. Yeah. I did install Docker. Okay, that's good. Good. Get out of there. Get out of there. Oh my God. Okay. So what we're going to do is we're going to go to the Docker GitHub, and I want to show you a little flame war that's going on in the Docker GitHub. Docker. I saw this really interesting. There it is. Oh my God. Look at this. So, support for Docker Desktop on Apple Silicon. This was an issue created on August 7th. So it's been like a long time. This was like very preemptive. And this just became a giant flame war. Like, look at this, 81 downvotes because people are putting pressure on the devs to port Docker to Apple Silicon. And we could just follow this flame war all the way down to 15 days ago, 12 days ago. And people are trying to be encouraging to the devs. It turns out 7 days ago, EC2 Mac instances with Apple M1 are already in the works and planned for 2021 on Amazon Cloud. So you can use M1 in the cloud. You don't even have to buy M1. So 4 days ago, G. Petrov got Docker Desktop Preview to run perfectly on the Apple Mac Mini M1, which is what I bought. It runs on x86. So that's good. So it's not that I didn't get Docker to install. Like here's Docker right here. It's just you run Docker, but then you get this incompatible CPU detected error, but your hardware is incompatible. This version of Docker Desktop requires an Intel processor. For learn more about this issue, go to docs.docker.com/Apple. Okay, here we are, support, and make sure certificates are set up correctly. Run Docker run. Okay, Docker run. Okay, so Docker's installed. We got Docker to install. And the way to get Docker to install is to just run the manual desktop installer, which is not even a terminal app. It's just a binary. But it's basically just Docker desktop for Mac. That's it. Or Windows or whatever it is. And it's like install. And you download Docker Hub and that installs it. So that's Docker. But what about Python? Let's see, let me make this really big because we're about to do some serious Python hacking. So what version of Python do I have? I have Python 2.7. Okay. What about, do I have Python 3? I've got Python 3.8. That's good. Do I have pip installed? I've got pip installed. Good. Okay. What else do I want to see? I want to see what the version of the chip I have. So Mac C chip version, I think it's like sysctl is the command. Sysctl-a grep macdep. That shows us our processor in terminal. So if we go back up here and make this smaller and move it to the corner and paste it. That sources our bash. That's not what we wanted to do. Hold on. What we want to do is we want to copy this. We want to paste that command in, and we want to make sure that this is running. Look at that. Apple processor, CPU brand string, Apple processor. That's what we like to see. 8 cores per package. So we've got 8 core GPU, 8 core CPU. Actually, the GPU is not listed here. It's just the CPU and the cores. But definitely running an Apple processor. Docker Hub doesn't like it. But that's fine. We got Docker to install. It's just a binary, but like kind of install. It's not like fully installed. Yeah, whatever. Let's see the latest of all the tools. The tool we care about the most is TensorFlow, and Apple themselves ported TensorFlow to M1, which is amazing. That's what they should be doing, right? If you're going to introduce this very proprietary hardware and you expect the open source community to use it for their projects, you better write a binary. So good job, Apple, on taking a good first step. I really don't like you overall, but I will use my MacBook, and I will say that Facebook is much better at hardware innovation with their Reality Labs and their Oculus Quest 2, and Apple is a joke when it comes to actual innovations. Maybe the AirPods were great, but overall, I just need you to know that I really don't like Apple. I'm just doing this M1 video because we want to push deep learning and machine learning and AI forward, no matter what it is. We're not too tribal about our brands. We'll use whatever tool is going to fit the job. But overall, I don't like that we have to write like Apple specific code for anything. So here's TensorFlow Mac OS, and it's just a script. So you don't see anything. So let's look in this script. Let's see like what this guy did. It's just like 2 bash scripts, and it's pulling TensorFlow. It's pulling TensorFlow from their own repository inside of like the preview. So they basically pre-built a single binary that you download for TensorFlow, and it's like locally on GitHub. So we can do that. Let's just do that. So we've got TensorFlow Mac OS. And so what do we have to do? We have to, where's the installation steps? There is none. Okay, so let's just download it. So we'll do code, download zip. Yes, allow GitHub to download things. And now we'll CD into it. TensorFlow Mac OS. Boom. Now what do? Now it says, quickly copy and paste this into terminal. Okay. Let's copy and paste that into terminal. And bad pattern. Oh. Hold on. Nope. That's not going to work. Okay. So, yes, we want to install that. Go. Look at that installing TensorFlow, just like that. So it's installing. Now, I don't want to lag my stream too much, so we're going to stop the download. I actually already have TensorFlow installed. Once it's installed, then we have to source that environment using the source command. Where is that source command? Source. I know it's one of these. It's like source TensorFlow. Here it is. It's source TensorFlow Mac OS bin/activate. What that does is it creates a virtual environment. It's kind of like a mini Docker for TensorFlow, installs all the dependencies in there, so you don't have to deal with like versioning issues or any of that stuff. And that's why we have this. So now we're inside of our environment. And once we run that, we can open up a Jupyter notebook, which I already have running here. So I have this Jupyter notebook. Guys, got some great questions coming in. Keep them coming. I'm going to answer them just in a second. I want to show you this Jupyter notebook I have running. So I have this Jupyter notebook running. I just run Jupyter Lab in terminal. And I can actually run it again. So let me just Jupyter Lab. Boom. Open up Jupyter Notebook, localhost, and you see this. So basically, I found this like toy TensorFlow code. I just wanted to test out if TensorFlow even works. And as you can see here, this is just a basic training loop on toy data. Match the input to the outputs, basic supervised learning with toy data. But you can see that when this code is compiled, we're getting some TensorFlow warnings, which is a good sign. It means that we actually got TensorFlow to install. The question, though, is it worth it? Now, let me make this bigger. These are the runtime errors that I was getting earlier before the stream. Check this out. Just like running the TensorFlow training loop, so that like the first part, like initializing the session, all that's going to run. But when you actually initialize like batch training and like the training loop, all these runtime errors show up. And that's because ML compute and TensorFlow were not properly ML compute was not properly encapsulated into the TensorFlow framework. So Apple did a very poor job of porting it over, of porting TensorFlow over to M1. Like, it's really terrible. Like, yes, it's going to run, but it's going to require a lot of tweaks and stuff like that. But we have a lot of code to write in a second. We have some code to write in a second. But before we write the code, let me remember to now ask the second question of our game. So let's get to the second question. Alrighty. So the second question of our game, I hope you guys are ready for this, is let's see. Hold on. Make sure this is all. Okay. Which activation function is this? We were just talking about machine learning, right? We're talking about Apple, we're talking about TensorFlow, and we're talking about Apple's technology, their ML compute technology. So when it comes to neural networks are universal function approximators. They can learn any function. There's a function for everything in life. It just needs to be discovered. It's kind of like sculpting a statue. The sculpture already exists. You just got to whittle away all of the other material. And so neural networks are universal function approximators. They will find the function. And there's a formula to find any given function in the entire world, both linear and nonlinear functions, unbelievably. It's like one of the laws of physics out there. But it's a neural network architecture discovered in the 50s. And the idea is that we have an input data set or an input data point. We multiply it by an initial set of weight matrices. We add some bias value. We take that result and we perform the same set of operations again and again. We activate the result at the very end, and then we repeat over and over. So it's like input times weight, add a bias, activate, repeat, input times weight, add a bias, activate. Now, the activation function, why do we have an activation function? We have an activation function because we need these neural networks to not only be able to compute linear functions, which exist. We also need them to be able to compute nonlinear functions, which a lot of the world has. And so activation functions are, another word for them are nonlinearities, because they make our neural network able to approximate a wider range of values, a wider range of functions. And so this is a specific activation function. It's a very popular, perhaps the most popular one there is. And it's either a softmax activation function, a ReLU, rectified linear unit, that's what ReLU stands for, activation function, a leaky ReLU, which is a newer version of ReLU, or it's a TANH. And your job is to decide which of those four that math equation you're looking at is, where we're taking Z, where Z is a hidden state. It's that value from the previous layer, whatever that previous layer was. Remember, input times weight, add a bias, activate. The result is Z. Input times weight, add a bias. Before we activate, that's Z. We take Z and then we activate it. And that's going to output some value. And let me answer some questions let me answer 2 questions before we move on. 30 more minutes in the stream, guys, and then we're going to announce the winner. Do you think, Related Title asks, one of our legends, shout out to Related Title for winning so many games so far and hopefully many more. Do you think ML in ARM-based systems is better, assuming all the ML libraries are available for it as well? When it comes to better or worse, I think whatever gets the job done right now is better. And, because we have a world to completely, radically redesign using software and automation technology. And we have to free humans from labor and create this fully automated society where we're all fully actualized and creative and discovering things. And in order to get there, we need to make products and services that work today for people. And today, M1 does not work at scale or at production. It is not in any way reliable. Absolutely, I would never use M1 for any app or anything that my butt was on the line for in terms of a paid project, a paid product for people. I would never use M1. I would use something tried and true and tested. If you are an AI researcher, though, if you want to research new types of algorithms, I do think that there's something really interesting to be said about ML compute and about looking for performance gains on Apple specific hardware using Apple specific software, and then just making some kind of product specifically like maybe some developer tool for Mac for Mac developers. Maybe there's a product you can make for that to make deep learning easier. So that could be a product idea for your related title. Let's keep going. 2 more questions. Bonnie McInturf. Bonnie actually gave me the idea for doing M1. So shout out to Bonnie. Bonnie, M1 sucks, clearly. But do you have a list published of what to install to set up the M1? The video description, I have like the CUDA quick start guide, the TensorFlow GitHub repository, and then the Docker documentation. Those are the 3 keys that you need. And then Jupyter Lab, the Jupyter Notebook. But those are the 4. Definitely need to get better about adding helpful links in the video descriptions. I get better at those every week. Especially for the one in a few days, I'm going to add so many hardware resources. One more question before we answer this one. Someone who hasn't asked a question yet. Nadir Abdul Haq asks, with tools like Colab, how necessary is it to have tools like TensorFlow installed on your laptop? Great question. Colab is great for prototyping ideas really fast. But if you want to do anything serious, you should have TensorFlow installed locally. So, I think Linux is the easiest to use TensorFlow on. Do I use Linux? No. So who am I to talk? But Mac OS is it's a Unix variant, so it's very similar. And I have a Windows PC. Okay, let's answer this question. Let's see what the answer was. In 3, 2, 1, reveal. The answer was it's an A, softmax function. Basically, the idea is that the letters E that you're seeing is the natural number, which is used throughout mathematics. It's one of those constants that just makes things work. There's so many constants. The acceleration due to gravity in physics, for the Mandelbrot set, that minimum value in the Mandelbrot set to create those infinite fractals, or the minimum size that anything in the universe can be. There's the actual minimum size. I think, don't quote me, it's 10 to the negative 26th nanometers or something like that. There exists constants in our simulation of a universe, just like any simulation. And sometimes they can be used for learning in this case, or sometimes they can be used for other things like measuring, what else is it used for? Like measuring those Greek ancient the Doric columns, the natural number is used for that. So, it's all interconnected. That's the beauty of math. All right, now let's get into our last question. Before we get into our last question, we have to look at some more code. So let's continue here with some code. We're going to get some code going. But which code is the question? Which code do we actually want to use in this stream? Well, let me tell you, it's going to be, I think I want to use George Hotz library TinyGrad. Let's just get straight into neural engine hacking and see what we can do with that, because I think that's cooler. You guys just saw that basically the tool set that we know and love, it doesn't really work on M1. So don't buy M1. That's essentially the summary. Do not waste your money on M1. I'm going to return this laptop. I'm going to return this Mac Mini after this stream, if Apple lets me, because I don't want to waste my time with it anymore. And I've got a GPU, which is amazing, and a PC and a Mac, which is much better. But let's just try to trigger that neural engine, as they say. All right. Hold on. We're going to switch the Mac and keyboard between both of them. And give me 5 more seconds. Okay, here we go. M1. So what was that library that George Hotz was working on? I think it was TinyGrad or something like that. But he triggered the Apple neural engine, which is totally not public facing, by the way. Like they have this private framework for the neural engine, which is using ML compute primitives to basically what it's doing. It's very vague. They don't really describe it in detail other than it's like neural engine, great for ML. They don't talk about what are the specific matrix operations that are encoded into the hardware. But basically, if we think about TPU design, like how did Google design their tensor processing units? And how did they differentiate them with GPUs? Well, they took matrix add and multiply, and they fused those operations, and they created a single hardware location for two different operations. And why did they do that? Because the same set of operations occur for neural networks and deep learning. And that's what essentially I believe that neural engine is doing. They encoded some matrix operations into the hardware so that they're faster because they're the same operations that are going to happen over and over and over again. But I think like the easiest way to trigger this is to just like start with this library. So that's what we're going to do. Let's download this library. All right. And like they have bindings to their private neural engine library, which is essentially performing those math operations very close to the metal on the CPU, and it's returning those values. It's percolating up those values up the set of layers up until we get to CoreML. But Apple doesn't want to expose what's happening there, which sucks. Like that totally goes against our open source mentality. But it's Apple. You know what it is. So we've got this library. Let's CD into it. All right, so we've got TinyGrad. And so look at these beautiful examples. Like I love this. So Andrej Karpathy, the head of AI at Tesla, probably the only person I'll ever get starstruck from. The only person I've ever actually been starstruck when I met was Andrej Karpathy, but everybody else is like, even Elon, it's like, yo, what's up, bro? But Karpathy is the director of AI at Tesla, and he's the reason that he's one of the big reasons that Tesla's autopilot is so cool. And he wrote this library called TinyGrad, Micrograd, and then George Hotz basically created a wrapper around it. And so we're going to install this library using pip3. So let's just get right into it. All right, we're installing TinyGrad, and then we're going to open this. We're going to like run this same example. Let's like run the TinyGrad example, and then we're like mess around with it, modify it, and then see if we can trigger the Apple neural engine from it somehow. We'll see how we can do that. So while this is installing, Ishan's like, will you give away the Mac Mini? You know, Ishan, I wish I was totally made of money. For you guys, but let me think about it. Like I've already committed to the weekly prize money. I think that's a big thing so far, but I'll definitely consider it. Let me say that I won't return it tomorrow. I'll give it a full day to think about it. All right, but good point, Ishan. So okay, it installed. Now let's we've got TinyGrad installed, and now we want to run Jupyter Lab, and we're going to test out this code. So Jupyter Lab, and that's going to be our, what are you talking about? All right, well, I've already got Jupyter Lab installed. I've already got Jupyter Lab running right here. So we're going to, inside this, we're going to open a new notebook, and we have TinyGrad running. No module. Okay, fine. Let's run that pip3 code inside of this Jupyter notebook to make that easier. And then we'll have TinyGrad inside of this repository just so that we can use it. All right. I think it needs to be like that, right? Yeah. Okay, so now TinyGrad is installing inside of this. And while this is installing, it's successfully installed, we will now run TinyGrad. Good. Good. Haha. Okay. So, okay, TinyGrad's working. Look how easy it was. So that was working. I think we've got TensorFlow, import TensorFlow STF. Shout out to TensorFlow. TensorFlow's installed, good. And you know it's installed because if I was like import TensorFlow, if I misspelled that, it's like, wait, what? What are you talking about? I don't know what that is. So TensorFlow is working. TinyGrad is working. The performance gains aren't as much as we would like. Like we need better performance gains than what M1 is providing us. So, okay, we've got this tiny example working, and now we want to like try to trigger the neural grad thing. So how do we do that? It's like, let's look up like trigger torch dump. Like we want like a data dump, not PyTorch data dump in like Python. Is there like a way to do that? That would be insanely cool. Like I'm learning it out in the open, guys. I saved a little bit of my learning for you guys so you can watch how I like learn things, because people will try to convince you that it takes a really long time to learn a lot of things. But that's not true. You can actually learn the same amount of things in a very, very short amount of time. You just have to believe in your ability to learn. Also watch my video, How to Learn Fast. That's like, I have so many like how to learn fast videos, just like Learn Fast Siraj. I got like 3 great videos on that. So how do we trigger this thing? Let's run this. Let's run this like sample torch script and see if that triggers anything. Basically, we want like a data dump of what it's doing behind the scenes. So no module name torch. Of course, we didn't install PyTorch. I don't want to actually do it. I want to do TensorFlow. Let's do. Give me like, guys, give me like 5 more minutes, and then I'm gonna ask the last question and answer all of your great questions coming in. TensorFlow 2.4 is here. I want like a TensorFlow gist that shows data dump of like Python training, like inference. You know what I mean? Like I'm looking for some kind of yeah, like the protobuf, like the generated binary. Like what are these commands? Add post processing ops, visualize. No, none of this stuff. What I'm trying to do, like we want to basically like a graph model that encodes like, so basically private framework, Apple, neural engine. I wonder if this is even like on the web. It's like test A&E. Oh, okay, there we go. Who is this? Wait, this is 2 years ago? What? Okay, this was a different neural engine. I guess they had different neural. It's easier to trigger it from Swift than it is from here in this view controller. It's easier to look at that. That's what it's called. You have this NS bundle. So NS is like a lot of Apple libraries start with NS. Next Step, which was Steve Jobs' next company after Apple before he came back. But a lot of the code that was developed there, they ported back to Apple. So that's why you see a lot of NS. And this is Objective-C. Or actually, is this Objective-C? It looks like Objective-C. Yeah. Or is it Swift? No, it's Objective-C because it's got the .h. Okay. See, this is the kind of thing that would trigger neural engine, but we would have to be running Swift. Do we want to install and run Swift? I guess so. Can we run Swift from terminal? That would be insane. Swift from terminal. Oh yeah, it's like Xcode select, right? Sudo. Let's see how that works. Haha. Invalid. Oh, because I didn't even like install Xcode select. What about this? One of these is going to work. What? I don't even have like Xcode or Swift installed. I was like, I don't care about that. How about this one? User environment execute run. See, I don't even have any of the like developer tools. That's why. How about like? How about not even user bin? I was just like Xcode run. Do I have that command? Yes, I do. SDK, Mac OS X, Swift. Something's happening. It's fine. Let's just like write something. Let me just like write some code here. Let's see. So what do we want here? So we've got our tensors. We have our like input data, and then we have our like matrix multiplication. So this is like I guess you could call this machine learning, but it's like one iteration of the training loop, one loop, right? So it's like matrix input times weight add a bias. There's no bias here, and then we back propagate with this backward pass, which is the learning process. Search back propagation Siraj on YouTube. I literally have a 5-minute video that will describe back propagation to you. I made like 3 years ago. So we have backward propagation, we have one loop, and then we print out the result. We're actually printing out the gradients, which is computed. Okay, yeah, that's fine. But we want to increase this, instead of one loop, let's have this be like 10 loops. So we'll add like a training loop here to make this like legit machine learning and, right, neural networks. Where's your like training loop stuff? Okay, so you had it like the simple function from testnet, GPU support. Oh, let's see that GPU support. Like, where's that at? Ooh, that's what we want to see. What was like going on here with like TinyGrad? No module name ANE. Right? Apple Neural Engine. That's what ANE is. Apple Neural Engine. Yeah, so we need 4 basic operations. TinyGrad ReLU CPU. So ANE is not, do not rely on the ANE. It's seg faults, right? That's right. So, we have to add like this like IO kit user access entitlement to the Python library. Look at how convoluted this is. Even if George Hotz made this like super easy, 3.5 stars. That's amazing. Go give it a star. Even though he did that, it's still like such a pain to install anything. And PyTorch definitely doesn't have anything for M1. Like, I would be so surprised if PyTorch had something. Look at that. November 10th. Watch this flame war. I haven't even seen this. Watch this flame war. Everyone's going crazy. Any updates? Sorry, Sharon. It's no updates. Nobody cares. All right. Let me ask you the last question. All right. Who is ready for the last question? I know I am, because it's going to be dope. All righty. Let me begin accepting answers. Okay. So my last question for you isn't actually a multiple choice question or a math input question. It's a new type of question. It's a short answer. We're experimenting here. So my question for you is, describe one thing you learned today in one sentence. You can just say, I learned something about M1, just anything. It doesn't have to be anything in particular. I just want to know that you guys learned something. Maybe you learned what the word x86, today I learned what the word x86 is. Today I learned that there are 2 different major types of processors. All these things. I don't want to take too many of yours. But there is no wrong answer for this last one. Basically what I'm going to do is I'm going to see who answered the first 2 correctly. And then for the third of those remaining ones, we're going to have 3 winners. We're just going to see, I'm grading this last one based on relevancy. So if you mentioned anything in this last one that I talked about during the stream, then that's going to be valid. There's no wrong answer unless you say something like totally like, today I learned about like how aliens fly. I didn't talk about that. So, all right. And so while you guys answer these, I need to answer 3 of your questions before we announce our winners. All right. So 3 questions. Question 1. Finber asks, how long do you think this entire transition period is going to be for open source platform to support M1? Should first-year computer science students buy the M1? Please do not buy the M1. Please do not waste your money on the M1. I have done that for you. I have wasted my money for you. Don't buy it. Just get like a cheap Linux laptop. Just don't look at the marketing. Just look at the CPU, clock rate, frame rate. Look at the GPU, how much video RAM is there. Linus Tech Tips, I love that guy on YouTube. I love his show. Watch it all the time. Watch him. Learn a lot about hardware just by watching his videos. And don't buy into Apple's marketing hype. The AirPods were the greatest thing they've made since the iPhone, in my opinion. And the next great thing they'll make is probably going to be a virtual reality device after, Facebook has already invented everything for them. And then they're going to say, oh, this is revolutionary. You know how it is. 2 more questions. Pie Pony asks, Siraj, you said a book earlier that you read. What was the name and where did you hear about it? Let me say this once more so you guys, it's a really great book, guys. And it gets really good 50% into it. It's called Metamorphosis of the Prime Intellect. And I actually heard about it from George Hotz, who's my friend, and he's a hacker or streamer. And he was talking about it and he read it. But basically the story is, it's a sci-fi book about in the future, there's this artificially generally intelligent super intelligence called prime intellect that's basically like a god and essentially does everything for humans. Death is gone, disease is gone, all problems are gone. Human nature, the fundamental flaws of human nature are gone because prime intellect got so powerful so fast that it rewrote the entire simulation to be in control of it. So it basically became God of the universe, starting with this very small, essentially, algorithm. And I think it's a really amazing book and really inspiring. And I think everybody should read it. I'm not done yet. I spent 2 hours last night reading it, but great fiction book. I think it's important for us to read fiction books, not just nonfiction all day, because fiction books are fodder for imagination. And what more could we as independent researchers and AI enthusiasts ask for than more sources of imagination to build our algorithms towards? One more question. Pranav Desai asks, I'm not able to understand how text mining and NLP are different. They're not that different. NLP is a newer, they're not that different. Text mining is a subset of NLP. It's not that different. We also shouldn't be caught up in all of these keywords, in different fields, there are different words for the same thing. Physics has a word for vectors. Machine learning engineers have a word for vectors, and they're different, right? Linear algebra, there's a word for, linear algebra. Let's not get too confused here. But sometimes across different science and math disciplines, similar words are used. So text mining and NLP, you can think of text mining as you're mining through text data, and that's what you're doing every time you're doing natural language process. You're processing natural language, which is text data. So I'm, kind of mad at us or whoever invented all these terms for confusing students. But look, it all starts and ends with the data. What you start with, what data type you have, whether it's text, whether it's images, and then you decide what the algorithm to use is. If it's image data, you know to use convolutional networks. If it's text data, you know to use recurrent networks, LSTM networks, transformer networks, etc. If it's video data, same thing, because videos are frames of images. Now, okay, I got to talk about AlphaFold before we end this. Guys, AlphaFold is truly amazing. And I think that I have really been caught up in the hype of AlphaFold and protein folding, and I made several videos on AlphaFold. If you just search AlphaFold Siraj, you'll see some really in-depth videos on how AlphaFold works. But all the experts say, yes, it is a huge discovery, absolutely, but it doesn't necessarily mean AlphaFold will be useful for anything other than protein folding. I know that's something that we like to think and we kind of project onto these algorithms because we want generalizability, but I honestly don't think AlphaFold will be used for anything outside of protein folding. I do think that AlphaZero could be used for energy optimization, which is a different algorithm for Go and all those Atari games. But all that is to say that DeepMind is very much focused on accelerating science, which I love. And AlphaFold is exactly in line with that mission. But, I got Eric Alcaide was his name, a student in Barcelona, to recreate AlphaFold 2 years ago, and he called it Minifold. If you search Minifold on GitHub, you'll find it. And I sent him a GPU for doing it. It was a Titan, and I partnered with NVIDIA to send it to him. But that was really inspiring to me. Basically, what I'm trying to say, guys, is that AlphaFold is an amazing discovery, but don't be too impressed by it to the point where you think that you could never implement anything like that, or it's outside of the realm of what you can learn and understand. It's not. Search Minifold on GitHub if you want to see an open source version of AlphaFold that somebody in our community built. All right, so now let me end this and let's see who the winner is. I'm gonna finish and reveal. Let's see all of these. Okay, I got some hilarious responses. I will now announce the winners. So I'm now reading through the results. All right. You guys have some hilarious short answers, by the way. So related title again wins. So related title is one of our winners. Related title got all of those questions correct, and not only did he get all the questions correct, his answer was, I learned a lot about doing ML on the Apple M1 and its performance and reliability or lack thereof. I never really thought about doing ML on ARM-based systems before. That's a perfect short answer. Let's see who else. So we've got related title is one. Magnus Fredslund. Magnus Fredslund is a winner too. Magnus answered all his questions correctly, and his answer was that the M1 chip is not yet useful. True. That's essentially how you could condense all of this. So we've got Magnus Fredslund and related title. And we have one more winner, and one more winner is Thiagarajan. Okay, Thiagarajan is our third winner. Thiagarajan. Let me write that down. Thiagarajan said, I learned about CoreML and had a great discussion about ML ops. Thanks. Great. Awesome. Great to hear. So we have our three winners. We have Magnus Fredslund, related title, and Thiagarajan. Congratulations, you two. Everybody, congratulate our winners in the live chat. All three of you, email me, hello@surajraval.com within the next hour with your Bitcoin address, and I'll send it to you within 24 hours, all right? But please do send me an email within the next hour, and that just prevents like phishing and stuff like that, all right? So super excited about that. Congratulations to our winners. I have to end this with a rap for you guys. So I'm going to do a freestyle rap about our winners. We'll see if it works. Let me just start the freestyle. Yeah.
Bitch, there's a goat house.
Yeah. Halo 2 remix.
Woo!
Here we go. What am I going to talk about? I got my neural engine, I says it, I make it work. Related titles got the beat as he does it at work. Got 8 core GPU, I got my 8 core CPU on that neural engine. Registers running, every location, it's got every single YOLO class library done it. Yeah, I mean this beat is mostly sick. I just wanted to hear it, you know what I'm saying? Hey, let's see. M1 sucks, Apple sucks. Yeah. We do our open source tools on Linux, Unix, and Windows. Yeah. Damn, this is fire. I love this beat. Who else is excited for Halo Infinite? Also, Cyberpunk 2077 just came out. I don't have time to play because we're focused on Code Royale and turning this into the greatest machine learning educational experience of all time. But I will play at some point. Guys, I thank you so much for being here. I really love all of you. And I can't wait for you to be here for the stream on Friday. So I have a Friday stream. I'm going to schedule it in the next few hours. So keep an eye out for that next stream. We're going to build this GPU, this RTX 3080. And we're going to build an entire PC from scratch live. So I hope you're there for that. Thank you guys for being here. Shout out to our sponsor, Zilliqa. Zilliqa is a blockchain, and they are the reason that I'm able to give you guys some money for these rewards every single week. So shout out to Zilliqa. They have implemented sharding. They're a great blockchain, and we love Zilliqa. Thank you guys, because I love giving my community rewards. So Zilliqa, love you guys. Shout out to you guys. There's a link to Zilliqa in the video description. Great community as well. And also Play Code Royale. If you haven't signed up for the waitlist yet, sign up for Play Code Royale. It's a free-to-play game. I'm so focused on making this the best, highest quality educational experience for machine learning in the world. I'm so committed to it. Thank you guys for being here. I love you, and hope you have a great day, great night, wherever you are in the world. And I will see you in a few days.